So, good morning, everyone. In the last class, we were discussing about the concept of the climate, and we covered various type of climate, like British type. We have covered. We have covered what the Mediterranean type. We have covered the China type. We also covered the grassland type. We also covered the polar type. So those type of climatic conditions we have covered. So what is the name of the temperate grassland in case of the Central Asia? What is the name of temperate grassland in case of Central Asia? Steppe. Yes. Okay. What is the name that is given in the case of Hungary or Europe? What is the name that is given in Hungary or Europe? It is Pustaj. Where it is known as Pampas. Yeah, it is known as Pampas in case of South America, where it is known as prairies. Prairies in North America. Yes, okay. In North America, in Canada and America, it is known as prairies. Okay. Which part is known as the granaries of the world? Prairies. Yes, okay. Prairies are also known as granaries of the world. So that also we have covered. Prairies are also known as the granaries of the world. Fine. Then we also discussed the various type of what? Various type of the vegetation. Which type of vegetation you are finding in case of temperate grassland? Which type of vegetations you are finding in a temperate grassland? Temperate grassland. Short grasses with no trees. Okay, temperate grassland. Which type of vegetation you are finding? Short grasses with no trees. Clear? Where do you find a short grasses but scattered trees? In savanna region. Yes, okay. Grasses but scattered trees is in tropical grassland, and no trees in which grassland? Temperate grassland. So those things we have covered with regard to tropical and temperate grassland. Fine. Which region is known for winter rainfall only? Which region is known for winter rainfall? Mediterranean region. Fine. Which is known for orchard farming? Which is known for orchard farming? Again, Mediterranean region. Yes, Mediterranean region is known for orchard farming. We discussed they are known for citrus fruit cultivation. Clear? Then we discussed the absence of shade. The trees not having shade is a feature of which type of climatic condition? Trees not having shade is a feature of which type of climatic conditions? Again, it is a Mediterranean. Mediterranean, what are we have written? The trees are short in nature. They do not have a shade. Absence of shade is a feature of whom? Absence of shade is a feature of Mediterranean type of climatic conditions. Fine. Which type of climatic condition get rainfall of around 60 to 150 centimeter? Which type of climatic region gets a rainfall of around 60 to 150 centimeter? 60 to 150 centimeter. Yeah, China type. So China type get rainfall of around how much? 60 to 150. What is the difference between China type, Natal type, and the 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 Gulf type? What is the difference you are finding between China type, Natal type, and Gulf type? China type is monsoonal, Gulf type is what? Slightly monsoonal, and Natal type is what? Non-monsoonal. Clear? Rainfall can happen throughout the year in Natal type. So that differences we have discussed between China type, Gulf type, and Natal type. Which type of region is known for truck farming? British type. Yes, British type is known for truck farming. Which type of region is known for coniferous forest? Coniferous forest. Taiga region. Yes, okay. Taiga is known for coniferous forest. Clear? Yeah, Laurentia also have there, but it is a Laurentia has a mixed type of, okay, it has a coniferous also, it has a deciduous also. Coniferous is mainly feature of which type? Taiga type. Fine. Then we also discuss in which type of climatic condition you'll find Eskimos, tundra type of climatic conditions. Yes, okay, Eskimos are found in polar type, tundra type of climatic conditions. Fine. So those are climate we have discussed. Now we'll start with concept of jet stream. Fine. So we have discussed this type of, okay, what this type of nothing but, okay, convection. We discussed which cell it is called as, a Hadley cell, which cell it is called as a Ferrel cell, and which cell it is called as polar cell. Fine. We discussed this is equatorial low pressure belt, this is subtropical high pressure belt, this is subpolar low pressure belt, and polar high pressure belt. Fine. So these are the pressure belt we have discussed. We discussed when you are moving from equator towards something but, okay, pole, the troposphere height is what? Or tropopause height is going to be what? Going to decline. Why it declines? We discussed, if you remember, troposphere is around how much height? Troposphere is around 18 kilometer height. Yes, it is around 18 kilometer height. And by the time it reaches over here, it is how much of height? 8 kilometers. So we discussed troposphere varies. Okay, troposphere varies in height. It is around 18 kilometer over here and 8 kilometer over here. Fine. So this is what you are finding with regard to what? This is what you are finding with regard to the cells that we have discussed. Fine. Now imagine, this is a column of air. This is a column of air at the equator. I'll just make this. Now this is a column of air at the equator region. This is present at which region? This is present at equator region. Now suppose this column of air is now moving towards where? This column of air is now moving towards where? Towards nothing but, okay, the polar region. This column of air from equator is moving towards polar region. You know that from equator it rises up, then, okay, move towards nothing but, okay, what? Move towards nothing but, okay, polar region. Assume this is a column of air. Now it is moving towards polar region. When it will move towards polar region, what will happen? When it will move towards polar region, what will happen? You'll find this is how the column of air is going to be there. So this is how you are going to find this column of air. Clear? So same column of air, when it is moving from equator towards the polar region, we'll find this much. This is the column of air. So as the air is moving from where to where? As the air is moving, this column of air is moving from here, that is equator, toward the polar region. What will happen? What will happen? What will happen when you see a column of air moving from equator towards the polar region? You'll see what its volume, air volume will what? Decline. Okay, so it becomes more denser in nature. It becomes more denser in nature. So as you are moving from here to here, as we discussed, tropopause is declining. Height is declining. Why this is declining? Because air is what? Air is becoming denser in nature. You know that equatorial high temperature is there. At the equator, what will happen? You have high temperature. High temperature means what? High temperature means what? The volume will increase. But as you are coming to the polar region, temperature will decrease. So what will happen to volume? Volume will decrease. Okay, so volume of air is something that is decreasing in nature when it is moving from here to here region. Clear? Any doubt regarding this particular part? So this is how, when the column of air moves from this region to this region, its volume starts to decline, and as a result you see height of, okay, what height is something that is, okay, declining as we are moving from here to here. Clear? Any doubt regarding this particular part? So this is, okay, what this is a the less denser hot column of air. This is more denser cold column of air. Clear? So as it moving from here to here, you are seeing less denser is becoming nothing but, okay, more denser in nature. Fine. Now you know that when the air is, when at the equatorial region, you know that air is heated up. So air, what happens? It expands and it rises up. Okay, so at equatorial region, air is heated. When it is heated, it expands as well as nothing but, okay, rises up. So when it rises up, what will happen? When it rises up, what will happen? It expands and rises up. What happens? So here, which pressure is created? Equatorial low pressure region is something that is, okay, created. And we discussed when it rises up, it diverges. Okay, it diverges like this in this hemisphere. And when it diverges, it starts to what? Starts to sinks down at which pressure? Subtropical high pressure. Starts to nothing but, okay, move down at subtropical high pressure belt. It starts to comes down at a subtropical high pressure belt. Now similarly, from subpolar low pressure belt region, the air will rise and air will nothing but, okay, starts to diverge from here. Air will starts to diverge from here, and it subside at which region? At the polar high pressure belt region. So this is subpolar low pressure belt region, and this is nothing but, okay, polar high pressure belt region. Clear? So this is how convectional current are something that are formed. So which pressure is generated over here? You know that air always moves from where to where? High pressure to low pressure. So equatorial low pressure belt which is created. So from low pressure to, you see, current is something that is, okay, rising. And from here to here, we discuss which wind flows. From here to here, which wind flows? Westerlies. No. We discussed from here to here which wind flow? Northeast trade winds. Okay, so from subtropical high pressure belt to equatorial low pressure belt, which wind flows? Northeast trade wind. From here to here, which wind flows? Yeah, southeast trade wind. From here to here, you will find the blowing of southeast trade wind. So at lower pressure, you see high pressure is formed over here and low pressure is formed over here. As a result, wind moving from where? Wind moving from high pressure to low pressure. Wind moving from where to where? High pressure to low pressure. But what is happening in the upper atmosphere? What is happening in the upper atmosphere? You know that when air is rising from here, air is expanding from here. So what will happen? Low pressure is created at the bottom. But what happens at the top? What will happen at the top? When air is rising, it is creating a low pressure at the bottom. What will happen at the top? What will happen at the top? Here, what will happen? Here, there will be creation of what? Which pressure? Here, there will be creation of high pressure. In upper atmosphere, what will happen? High pressure is going to be created. Why high pressure is going to be created? Why high pressure is going to be created in upper atmosphere? Why high pressure is going to be created in upper atmosphere? Because all the winds are compressing where? These all winds that are rising are compressing where? Compressing in this particular region. So what pressure is going to be created? High pressure is going to be created. Clear? From here, expansion is happening. At the lower part, expansion is happening. But at the higher part, what is happening? Compression is happening. Compression means what? Which pressure is going to be formed? high pressure is going to be formed. Okay, so remember that what we discussed. Okay, at the equatorial region, more sunlight means heating will happen. As a result, here at the lower, you see expansion is happening, but at the high level, what will happen? Compression will happen. When compression is happening here, which pressure is going to be formed? High pressure are going to be formed at the upper atmosphere. Clear? Now what here is happening? Here what is happening? Subtropical high pressure belt. Subtropical high pressure belt is okay being formed over here. When subtropical high pressure belt is being formed, how the high pressure will form? When the things will compress, okay, then only what will happen? High pressure is going to be formed. So here air is sinking down, air is compressing. So which type of pressure here will be formed at the upper atmosphere? Low pressure. So here what will be formed? Low pressure is going to be formed, because from the low pressure, from the here expansion is happening. That's why, okay, at the bottom what is happening? Contraction is something that is okay happening. So here what is formed? Low pressure. That's why wind moving from where to where in the upper atmosphere? High pressure to low pressure. Okay, so wind in the upper atmosphere also moves from where to where? From high pressure to low pressure. Clear? Any doubt regarding this one? So what is happening at the ground? Opposite is happening at what? At the top. Okay, so what is happening at the ground? From here to here wind is blowing. At the top what will happen? Opposite will happen, and from here to here wind will flow. So here you will see formation of which pressure? High pressure. Here you will see formation of which pressure? Low pressure. So wind moving from high pressure to low pressure. Now you know that in upper atmosphere what happens to the wind? In upper atmosphere what happens to the wind? In upper atmosphere what happens to the wind? Wind are only influenced by two forces. Wind are only influenced by which two forces? Pressure gradient force and Coriolis force. Okay, we discussed wind is not influenced by which force? Wind is not influenced by which force? Frictional force. In lower atmosphere, three forces are there. In lower atmosphere, what is happening? Three forces are acting. Which are the three forces affecting the wind? Pressure gradient force, Coriolis force, as well as, okay, what? Frictional force. But in higher atmosphere, only which forces are going to affect? In higher atmosphere, which forces are going to affect? Pressure gradient force as well as Coriolis force. Clear? So when wind are blowing over here, you see three forces are impacting: pressure gradient force, Coriolis force, as well as the frictional force. But when wind are moving in this part, then what will happen? Only two forces are something that are impacting. One is pressure gradient force, another is what? Coriolis force. Clear? So what is a pressure gradient force? We discussed pressure gradient force is what? Generated due to difference in pressure. So let's say this is, okay, what? High pressure zone, and this is nothing but, okay, low pressure zone. So as we discussed, pressure gradient force is going to drive the wind from where to where? Pressure gradient force is going to drive the wind from where to where? From high pressure to low pressure. So why pressure gradient force is created? Because we discussed some part is heated more, some part is heated less. So as a result, okay, you see nothing but, okay, this type of, okay, what? This type of movement is going to be there from high pressure towards where? Towards a low pressure. Fine. Second type of force, okay, that you are finding is which force? Coriolis force. Now what Coriolis force will try to do this? Coriolis forces tries to deflect. Coriolis forces tries to deflect this particular wind from where? From its original path. Okay, it is trying to deflect the wind from its original path. Clear? So as we discussed, because the earth is rotating, when earth rotate, what will happen? Let's say pressure gradient force is acting like this from high pressure to low pressure. By the time earth will rotate, this low pressure will come towards this side. As a result, wind has to what? Wind has to move towards this particular side. So what will happen is, because of the Coriolis force, deflection will happen. Clear? So wind is going to be deflected. So this part, okay, you have to keep in mind, which is happening due to what? Which is happening due to the Coriolis force. So due to Coriolis force, what is happening? Wind are being deflected from its original path, that is okay there. Clear? Remember, we discussed Coriolis force depends upon two things. What are the two things? What are the two things? What are the two things on which Coriolis force depends? What are the two things on which Coriolis force depends? One is latitude on which it is blowing, which is acting, and second is what? Second is wind velocity. So Coriolis force is Impacting what? Impacting nothing but, okay, it is impacted by two things. One is latitude and another is what? Wind velocity. We discussed Coriolis force is zero where? Equator. It is maximum where? At the poles. So latitude, if 0 degrees there, Coriolis force is zero. It is maximum where? At the poles, 90 degrees there. So Coriolis force is impacted by whom? Latitude. Okay, that is okay there. Clear? Second thing, we discuss wind velocity. We discuss wind is moving with a high speed, then what will happen? If the wind is moving with a high speed, what will happen? More deflection. If the wind is moving with a less speed, what will happen? Lesser deflection that is going to be there. Clear? So wind moving with a high speed, more deflection. And if the wind is moving with what? Low speed, then what will happen? Less deflection. So this is what you have to keep in mind with regard to Coriolis force. Coriolis force is impacted by whom? Impacted by latitude, and Coriolis force is impacted by wind velocity. It causes nothing but, okay, more deflection that is okay there. Clear? Now assume if the wind is moving with a less velocity, if the wind is moving with a less velocity, you are seeing slight deflection. You are seeing slight deflection. But if the wind move with a higher velocity, then what will happen? If the wind move with a higher velocity, then what will happen? You are going to see which deflection? More deflection. Clear? So as we discussed, high speed means more deflection, low speed means what? Less deflection. So when wind is moving with a low speed, what is happening? Less deflection is happening. But when wind is moving with a higher speed, what will happen? More deflection is something that is okay happening. Clear? So that's why we discuss in why you have northeast trade wind. Why you have a northeast trade wind? Because slight deflection is happening. But why we have westerlies? Because more deflection is something that is okay happening. Clear? We discuss westerlies looks from coming from the west side. Okay, it looks from coming from the western side because of higher deflection. Well, this looks like coming from which side? Northeastern side. That's why it is called as a northeast trade wind. So that's why we discuss it is okay. What? It is due to slight deflection. It is due to more deflection. That is okay there. So it becomes westerlies due to more deflection. It becomes northeast due to nothing but, okay, less deflection. That is okay there. So more wind will have more velocity, then what will happen? More deflection are going to happen. Clear? When wind will move with more velocity? When wind will move with more velocity? When there is absence of which force? Frictional force. Okay, so in higher speed, when in higher latitude, in upper atmosphere, wind is moving with what? High velocity. They are moving with a high velocity. Why? Because no frictional force is acting. Only which two forces are acting? Pressure gradient force as well as Coriolis force. Clear? So assume now this is a wind which is trying to move from high pressure region to the low pressure region. This wind is trying to move from where to where? High pressure region to the low pressure region. Ideally, so this is high pressure, this is low pressure. Ideally, the wind should move from where to where? From high pressure to low pressure region. Now, which force is acting in this direction? Which force is acting in this direction? Pressure gradient force. Which force is acting in this direction? Pressure gradient force. It drives the wind from where to where? High pressure to low pressure. While since Earth is rotating, the Coriolis force is acting in which direction? Coriolis force is acting in which direction? Coriolis force is trying to pull the wind or deflect the wind towards other side. Clear? Coriolis force is acting in which direction? Coriolis force is acting in this direction. While the pressure gradient force is acting in which direction? Pressure gradient force is acting in this direction. Clear? Any doubt regarding this one? If you remember, when we were discussing about the wind, we discussed pressure gradient force act perpendicular to whom? Pressure gradient force act perpendicular to whom? If you remember wind class, we discussed pressure gradient force act perpendicular to whom? Perpendicular to isobar we have discussed. Pressure gradient act perpendicular to whom? Perpendicular to the isobar. While the Coriolis force act parallel to whom? Coriolis force act parallel to whom? Parallel to isobar. Okay, Coriolis force we have discussed act parallel to whom? Parallel to the isobar. Pressure gradient force we have written as what? Pressure gradient force we have discussed Acting parallel to what? Parallel to isobar. What is isobar? Yeah, line, same pressure. Pressure is okay, isobar. Isotherm is temperature. Clear? So we discuss, let's say this is 1 millibar pressure. This place is 1 millibar pressure. So what will happen is, okay, this is a line joining, line connecting 1 millibar pressure. Let's say this is 10 millibar pressure. This is 10 millibar pressure. So this is line connecting what? Line connecting 10 millibar. So this is which pressure? High pressure. This is which pressure? Low pressure. So Coriolis force act perpendicular to which pressure? Perpendicular to which one? Isobar we have discussed. So Coriolis force always this pressure gradient force act perpendicular to the isobar region, that is okay there. Clear? So from here to here, pressure gradient force act high pressure to low pressure, it act perpendicular to the isobar. Clear? But we discussed, okay, Coriolis force deflect the wind. When it deflects the wind, it is acting perpendicular to whom? Acting perpendicular to the pressure gradient force. So acting parallel to whom? It is acting parallel to whom? Parallel to nothing but, okay, isobar. Since Coriolis force is deflecting the wind, it is moving in parallel to whom? It is moving in parallel to the isobar. So we discuss Coriolis force is acting parallel to isobar, while perpendicular gradient force, pressure gradient force is acting perpendicular to isobar. This we have discussed in earlier wind class. Fine. So what is what is the relationship between pressure gradient force and Coriolis force? So Coriolis force act perpendicular to whom? Perpendicular to the pressure gradient force. Coriolis force is acting perpendicular to which force? This is where pressure gradient force is acting. This is where Coriolis force is acting. So Coriolis force makes how much angle with pressure gradient force? 90-degree angle with the pressure gradient force. So Coriolis force act perpendicular to which force? It act perpendicular to the pressure gradient force. Coriolis force is deflecting wind in this direction, no? It is deflecting the wind in this direction. This is acting perpendicular to whom? This is acting perpendicular to the pressure gradient force, that is okay there. Clear? So what you are seeing is pressure gradient force is trying to pull the wind this side, while the Coriolis force is acting perpendicular to the pressure gradient force. So it is trying to pull wind this side. Clear? So initially at equator, what is happening? What is happening to Coriolis force? Initially at equator, what happens to the Coriolis force? Zero. We discussed Coriolis force is what? Zero at the equator. When this force is there, wind will always move. Wind will only move under the influence of which force? Pressure gradient force. So wind will start to move like this side. But what will happen when wind moves to this side? Now you see pressure gradient force is trying to nothing but, okay, move it to this direction. Pressure gradient force is trying to move it this direction, while now Coriolis force is trying to move it towards this direction. So as a result, you see the wind will be slightly deflected. Wind will be slightly deflected. Why? Because pressure gradient force is more as compared to what? As compared to Coriolis force. Coriolis force is increasing from 0 to certain level, but still Coriolis force is what? Coriolis force is small in nature. Clear? Now what will happen again? What will happen again? Now the pressure gradient force is trying to pull this side. Coriolis force is now trying to pull this side. Now Coriolis force becoming more stronger. So what will happen? You'll see now greater deflection is going to happen. Greater deflection is now going to happen. Clear? Now when, okay, what will happen? Now further what will happen? Now pressure gradient force will try to pull this side. Coriolis force is now trying to further pull this side. So wind will, okay, you'll see wind will, okay, move in this direction. Wind will move in this particular direction. So wind is moving in this direction due to which two forces? It is moving in this direction because of which two forces? Because of two forces. What are the two forces? One here is which force? Pressure gradient force. One here is which force? Coriolis force. Okay, so it is moving under the influence of two forces, pressure gradient force and Coriolis force. Clear? Any doubt regarding this one? So this is how deflection happens. Clear? So as we discussed, if Coriolis force is more will be deflection. If Coriolis force is less, then what will happen? Less deflection is going to be there. Or wind moving with a high velocity, more deflection. Wind moving with a less velocity, what will happen? Less deflection is going to happen. Clear? Any doubt regarding this one? So now assume in this one, assume that wind is moving from where to where? From high pressure region to low pressure region. When wind is moving from here to here, what will happen? What will happen? Two forces are acting. One is which force? This direction, pressure gradient force. And as we discussed, at right, what will act? At right angle, what will act? The Coriolis force. Okay, Coriolis force act as a right angle towards what? Right angle toward a pressure gradient force. So pressure gradient force is trying to pull, pressure gradient is force is trying to take wind this side, Coriolis force is trying to deflect the wind towards this side. So there is a right angle being formed. Okay, that is okay there. Clear? What will happen to this wind now? What will happen to this wind now, which is moving in upper air? Now this is going to be neither following this path nor following this path. What will happen? It will be now deflected. It will now be deflected. Clear? So it will neither move in pressure gradient force side. It is now not going to be move in the Coriolis force side. It is now going to move what? Going to be deflected. So it is neither moving in which side? Pressure gradient force side, neither moving in nothing but okay which side? Coriolis force side. So you'll see nothing but okay what? You'll see nothing but okay deflection is something that is okay happening. You'll find deflection is something that is okay happening. Clear? Any doubt regarding this particular part? So when the wind are blowing in upper atmosphere like this, from high pressure region to what? Low pressure region, because of this region, because of the Coriolis force, wind is going to be what? Wind is going to be deflected. Wind is going to be deflected. Clear? Any doubt regarding this particular thing? So let's say in this direction, now high pressure to low pressure I am moving, wind will be nothing but okay deflected like this. So they will start to move in upper atmosphere. They will start to move in a upper atmosphere like this. Clear? Rather than like this, because it is moving from where to where? From high pressure to low pressure. Rather than moving like this, they will be deflected due to Coriolis force. So they start to move in which direction now? Okay, yes, okay. In the northern hemisphere, we discussed winds are deflected towards which side? Coriolis force deflect wind towards which side? Right hand side. So now wind is deflected towards nothing but okay right hand side. When wind is deflected towards right hand side, in which direction wind will now flowing? It is moving from which direction to which direction? It is moving from which direction to which direction? West to east direction. Clear? When wind is deflected towards this side is west, this side is nothing but okay east. So wind is moving from now which to which direction? West to east direction. That is okay there. Clear? Now this is okay what we called as what? This we call it as a jet stream. Okay, this type of wind we call it as which stream? Jet stream. Clear? So in the upper level, when the wind is moving from where to where? From high pressure to low pressure region, because of the Coriolis force, wind is going to be deflected from its path. When wind is going to be deflected from its path, wind will start moving in which direction? Wind will start moving in which direction? They'll be moving from where to where? From nothing but okay the west towards nothing but okay east direction. And this type of wind is called as what? This type of wind is called as what? This type of wind is called as a jet stream. This type of wind is called as a jet stream. Fine. So basically clear. So this is how you are seeing the jet stream are something that are forming. Clear? How you are seeing movement of jet stream? So from equator, as we discussed in upper latitude, what is happening? Now from here to here we discuss which wind is flowing from high pressure to low pressure. In upper atmosphere we discuss wind is rising at the equator, moving towards which direction? Moving towards something but okay, this direction. Here what is being formed? High pressure. Here what is being formed? Low pressure. And because the wind are deflected at this particular side, wind will starts to deflect from here to here. Wind will starts to deflect. So wind start moving in which direction? From west towards nothing but okay, east direction. And this wind are called as what? These winds are called as a jet stream. These winds are called as what? Jet stream. Clear? Any doubt regarding this particular thing? So basically the jet stream are nothing but okay, what? This jet stream are the wind that are moving in upper atmosphere, not in lower atmosphere. They are moving in where? They are moving in the upper atmosphere. And from where to where they are moving? From where to where they are moving? From west towards nothing but okay, east direction. Why this their movement is from west towards east? Because wind are deflected towards what? Right hand side due to Coriolis force in the northern hemisphere. And as a result, you see when the wind are moving from here to here, they are deflected in this direction and they starts to move like this around nothing but okay, the earth. And this is okay, what we call as a which type of stream? Jet stream. Clear? Any doubt regarding this one? So remember that in upper atmosphere, what you are finding? So in upper atmosphere, what you are finding? In upper atmosphere, you are finding the wind moving from what? Wind moving from nothing but okay, one place to another place. In upper atmosphere, what you are seeing? You are seeing wind moving from one place to another place. So from here to here, you see nothing but okay, wind are moving. And when wind are moving from here to here, they are being deflected. They are being deflected like this. And when they are being deflected, they are moving from which direction to which direction? West to east direction. That is okay there. So assume this is nothing but okay, your globe. This is your equator. From equator towards nothing but okay, which region they are moving? Subtropical high pressure belt. They are moving from where to where? So we discussed where, from where they are rising. Equatorial low pressure belt. They are rising from here. And as we discussed, deflected towards here, then subsiding over here, forming which belt? Subtropical high pressure belt. We discuss what is formed over here. High pressure is being formed over here. What is being formed over here? Low pressure. So wind moving from where to where? From high pressure to nothing but okay, low pressure. But okay, they are not moving like this, rather deflected towards this particular side because of Coriolis force. And as a result, wind starts moving like this around the globe. They start moving like this, and this is called as what? This is called as your jet stream. Okay, this is called as nothing but okay, jet stream. Clear? So what is jet stream? The first thing that we have written is, the first thing that you have to keep in mind is jet stream are what? They are blowing in upper atmosphere. They are blowing in which atmosphere? Upper atmosphere. Blowing in upper atmosphere. Fine. The first thing that you have to keep in mind is blowing in which atmosphere? Upper atmosphere, not in lower. Lower atmosphere, what is blowing over here? Lower atmosphere, what is blowing? Which wind? Northeast trade wind. Yes, okay. Lower atmosphere, what is blowing? Northeast trade wind. These winds are moving where? These winds are moving in the upper atmosphere because the winds are deflected towards nothing but okay, right hand side. They are moving in the upper atmosphere. Second thing, they are moving from west to, they are moving from where to where? West to east direction. That's why they are referred as what? Upper level westerlies. They are also referred as which type of wind? Upper level westerlies. Clear? They are moving from which direction to which direction? West to east direction. That's why they are referred as which type of okay, wind? Upper level westerlies. Clear? Why upper level of westerlies? Because westerlies also blow in which direction? Lower atmosphere. From subtropical high pressure belt to subpolar low pressure belt, which wind flows? Which wind blows over here? Westerlies. From subtropical high pressure belt to subpolar low pressure belt, which wind blows? Westerlies. And from polar high pressure belt to okay, what? The subpolar low pressure belt, which wind is coming? Easterlies are coming. So westerlies are blowing in a lower atmosphere. But when jet stream are blowing from west to east, we call it as what? We call it as which type of westerlies? upper atmosphere westerlies or upper level westerlies. Clear? Any doubt regarding this one? So jet stream are referred as which type of westerlies? Upper level westerlies, not lower atmosphere. Don't confuse it with this westerlies. This westerlies is blowing in what? Lower atmosphere, while we are talking about this wind which is blowing in what? Upper atmosphere. So it is referred as which type of wind? Upper level westerlies. It is being deflected towards this side, so moving from where to where? From west towards nothing but okay east direction. So that's why this is referred as which type of westerlies? Upper level westerlies. Clear? Third thing, these are referred as circumpolar winds. These are referred as which type of wind? Circumpolar winds. Clear? Why circumpolar winds? Because they are moving with poles at the center. Circumpolar means what? They are moving with poles at the center. Clear? What the circumpolar means? They are moving with poles at the center, and that's why they are referred as which type of wind? Circumpolar winds. They are moving, they are called as a circumpolar. So let's say this is a pole, this is nothing but okay north pole, and this is nothing but okay south pole. Now this particular wind is blowing where? This particular wind is blowing like this. In the upper atmosphere, they are blowing like this, they are moving like this. Clear? So they are moving like this, that is okay there. So what is okay? The circle, what it is forming a circle. Circle means what is at the center? Poles are at the center. So that's why these winds are moving around what? These winds are moving with poles at the center. So if you see this particular figure, so if you see this figure, what is happening over here? They are moving with which at center? This is the center. This is the center you are finding, and okay, they are moving across this center. They are moving across this center. Okay, that is okay there. So which type of wind? Okay, it is going to be called as a circumpolar. Okay, it is called as a circumpolar. What is circumpolar means? What is the term circumpolar means? Circumpolar means what at the center? Poles at the center. Okay, remember that circumpolar is with poles at the center. It's getting delayed. I'll just write over here itself.
Jet streams are on the above atmosphere. So
Yeah, above.
The
The land surface. Fine. So what we have written regarding jet stream are, these are which type of wind? These are blowing in upper atmosphere. They are moving from where to where? West to east. That's why they are referred as what? Upper level westerlies. And the third thing that you have is what we have written? They are circumpolar in nature. They are which type of nature? Circumpolar in nature. Clear? Circumpolar means they are moving around Earth. They are moving around Earth with poles at center. With poles at center. They are moving around the Earth with poles at center. So they are okay. What? They are circumpolar in nature. They are moving around the Earth with poles at the center. Fine. Any doubt regarding this particular thing? So they are blowing in upper atmosphere. They are upper level westerlies. They are circumpolar in nature. They are moving around with poles at the center. Fine. Next, what information you have to keep in mind? How they are moving. How this wind are moving. You can see this wind are moving like this, no? You can see wind is moving in upper atmosphere like, not in a straight manner, rather what? Rather nothing but okay, wave-like manner. So we called it as which type of wind? Remember snake-like pattern? We discussed snake-like pattern is referred as what? Meanders. Okay, so we call it as which type of wind? Meandering winds. Okay, so we call it as which type of wind? Meandering winds. That is okay there. And this wave is referred as what? This wave is referred as a Rossby wave. This wave motion is referred as which type of wave? Rossby wave. Clear? So when wind moves in a snake-like pattern, we call it as which type of manner? Meandering manner. We call it as a meandering wind, and it is also referred as which type of wave? Rossby waves. Clear? So this meandering wind is referred as which type of wave? Rossby wave. So jet stream is which type of wind? Rossby wave wind or meandering wind, that you have to keep in mind. Fine. Then they are moving in a narrow concentrated band. They are moving in a narrow concentrated band with very high velocity. With a very high velocity. So they are moving in which band? They are moving in a narrow concentrated band with a very high velocity. Clear? What is narrow concentrated band means? That you can see what is the extension of this westerlies. The extension of this particular upper level westerlies is only this much. Only this much. This is a narrow concentrated. Concentrated means like this. Okay, they are blowing in this much area itself. They are not blowing like this. They are not covering wide area. They are covering only concentrated area, small area that they are moving over with. And this is referred as which wind? This is referred as a narrow concentrated wind. Okay, so this is not blowing over entire wide region. They are only blowing in a certain area. They are blowing only in a smaller areas. They are not blowing like a larger area. They are blowing only in a smaller area. That's why they are referred as which type of wind? Narrow concentrated band winds. Okay, that is okay there. Clear? And as we discussed, since they are blowing in upper atmosphere, what will not be there? What will not be there? Frictional force will not be there. When frictional force will not be there, wind will move with what? Very high velocity. Okay, wind will move with a very high velocity. So these are the characteristic of whom? These are the characteristic of jet stream. Okay, so if question comes, what is jet stream? Jet stream are the wind that are blowing in what? Upper atmosphere. They are moving from where to where? From west to east. They are referred as a upper level westerlies. They are referred as what? Circumpolar in nature. Circumpolar means they are moving around the earth with poles at the center. Next is what? Next is meandering wind. So they move in a meander like manner. Next, this meandering wind is also referred as Rossby waves. Next, narrow concentrated band. They are moving only in a narrow concentrated region. And lastly, you have which velocity? Very high velocity. So these are the characteristics that you have to keep in mind with regard to what? With regard to jet stream. Fine. Any doubt regarding this one? So now you know that what we just now discussed, wind are moving from where to where. This is how the wind are rising from equatorial low pressure belt, then moving in this direction like this, and then coming down. And then at the surface, this is Earth's surface. This is Earth's surface. We discussed which pressure is formed over here. Subtropical high pressure belt. Which pressure is formed over here? Equatorial low pressure belt. Which wind flows like this? We discussed this is a northeast trade wind. This wind is referred as what? Which wind? Northeast trade wind. Clear? And here lies which pressure? Here lies your subpolar low pressure. So wind will rise from here, subpolar low pressure, then move in this direction, and then starts to subside like this. We discussed this cell is referred as which cell? Hadley. This cell is referred as which cell? Ferrel cell. And here blows which wind? Here blows your westerlies. Okay, so here blows your at the surface which wind blows? Here at the surface westerlies, nothing but blow. Clear? So we discussed when wind are moving from here to here. When wind are moving from here to here, what is happening? This wind is deflected. This wind is what? This wind is nothing but deflected. When this wind is deflected, that is why you see this void. This here it is void being created. Here this is void being created. Why this void being created? Why this void being created? Because here air is what? Air is sinking. Here what is happening? When air from here is coming and where air from here is coming, what is happening? Air is sinking down. So when air is sinking down, what will happen? Here what is happening? void is being created because this was the air. Now if this air goes down, what will happen here? What is happening? Space is being created. Now this wind is okay, what deflected in this space only. This wind that is coming from this side is deflected in this void only, and that's why you see narrow concentrated band. We are saying that they are okay moving in a narrow concentrated band. Why they are moving in a narrow concentrated band? Because they are deflected in this band only where the space is being created. Okay, so in upper atmosphere where the space is being created, they are deflected at that point of time, that region only. That's why they move in which manner? Narrow concentrated manner. That's why they are not moving in a wide manner, not moving from here to here, because already here wind is flowing, already here wind is flowing. Void of the wind is created where? Here, because the air is sinking down. When air is sinking down, what will happen? A space is being created in the upper atmosphere. Let's say this is a lower atmosphere, this is upper atmosphere. From here wind is coming down. When wind is coming down, what will happen to here? Space is being created. So when wind is coming from here, it will be deflected towards nothing but okay this side rather than sinking down. That is okay there. Clear? So this is how the jet stream are created where? In the upper atmosphere, and it blows only in which region? It blows only in the narrow concentrated band region. So you are seeing jet stream, two type of jet stream are being mentioned. One is called as what? One is called as a subtropical jet stream, another is called as a polar jet stream. Two type of jet stream are mentioned. So subtropical jet stream are okay developed where? In this void. Subtropical jet stream are developed in this particular void. Okay, that is okay there. So it is created between which two cell? Hadley cell and Ferrel cell. Okay, so here you see which formation of which cell? Hadley cell. Here you see formation of which cell? Ferrel cell. So between Hadley cell and Ferrel cell, here you see in the upper atmosphere what is blowing? Subtropical jet stream are blowing. And similarly between Ferrel cell and polar cell, you'll see blowing of which wind? Blowing of nothing but okay polar jet stream. Clear? So between okay what? Between nothing but okay Hadley cell as well as nothing but okay Ferrel cell, you are seeing blowing of which type of wind? Subtropical jet stream. And between nothing but okay what? The subpolar low pressure belt and polar high pressure belt, that is between Ferrel cell and polar cell, at this concentration you will see blowing of which type of wind? Blowing of nothing but okay polar jet stream. Fine. Any doubt? So subtropical jet stream at this level, polar jet stream at this concentration level, you'll see blowing of these two wind, and that's why jet stream are classified into two types: subtropical jet stream and polar jet stream. Fine. So we divide jet stream into two types. We divide jet stream into two types. One is called as permanent jet stream and another is called as a temporary jet stream. Permanent jet stream and temporary jet stream. Permanent jet stream are of two types. What are the two types? Subtropical jet stream and polar jet stream. So subtropical jet stream and polar jet stream, these are the permanent jet stream. What are the temporary jet stream? What are the temporary jet stream? You have Somali jet stream and tropical easterly jet stream. Tropical easterly jet stream. Fine. So these are the two type of jet stream that you are finding: permanent jet stream and temporary jet stream. Permanent jet stream are subtropical jet stream as well as polar jet stream, while temporary jet stream are Somali jet stream as well as tropical easterly jet stream. Fine. Fine. So what you have to keep in mind is, what is jet stream? Jet stream are narrow concentrated wind. Where it is moving? In upper atmosphere. From where to where it is moving? From nothing but okay the west to east, and that's why it is called as what? Upper level westerlies. They are circumpolar in nature. They are what? They are moving with a very high velocity because frictional force is absent, moving with a very high velocity, circumpolar in nature, and as we discussed, they are okay what? They are okay Rossby wave or meandering fashion. Clear? Now, why the jet stream meanders? Why they meanders? What is the reason? Why do you think they meanders? What is the reason? Why do you think the jet stream meanders? Because of high pressures and low pressures. Where do you see? So we discussed wind is moving from here to where? High pressure to low pressure. Now from here to where? That is high pressure to nothing but okay low pressure. So what you see is okay. Why do you think here low pressure is there? No? Both sides you see which type of pressures are there. Low pressures are there. Wind is moving from where to where? High pressure to low pressure. High pressure to low pressure. Now wind is coming from here to here. What is happening? They are deflected towards this side. When wind is coming from here to here, they are deflected towards something but okay this side, leading to formation of what? Leading to formation of what we call as a jet stream. Fine. So why do you see okay this wind moving in a meandering fashion? Why do you think this wind is moving in a meandering fashion? Because of rotation of Earth. Any other thing? Any other thing? Why do you think okay they are moving? Now in the subtropical region you are seeing still what? If you see this particular thing, here you are seeing less movement. Here if you see winds are moving with what? Higher wave movement. Okay, winds are moving with a higher wave movement over here. Here the winds are okay like in subtropical jet stream here like movement you are there. In case of nothing but okay polar jet stream you are seeing much higher movement, much higher meandering that is okay there. Why this is happening? Because of earth heat gravity force. Any other thing? Due to land and water. Any other thing? Now remember we discussed when at the lower level we discussed when at the lower level which wind is flowing over here? Westerlies. Which wind is coming from over? When westerlies and easterlies meet, what will happen? When westerlies and easterlies meet, what happens? Yeah, the warmer will go up while the denser, okay, the colder will remain at the bottom. We say which type of okay things are not being fronts are being formed. Remember, when westerlies and easterlies are meeting, we discuss what is formed. Fronts are being formed. Warm front, cold front. Remember, the cold front is okay like this. Warm front is coming like this. Warm air is warm front. Cold air is what? Cold front. So when warm air is advancing, we form it as what? We form a warm front. When cold air is advancing, what is okay form? Cold fronts are being formed. So let's say from here which wind is going? Warm wind is going. From here which wind is going? Cold wind is coming. So when warm is advancing, you'll see like this. When cold is advancing, you'll see like this. So this is okay moving because of what? This is moving because of nothing but okay two contrasting winds are converging. Okay, so one wind is moving from where? Towards the equatorial region. One is coming from where? Towards the polar region. So one is colder, more colder in nature, another is what? Less colder in nature. So what you see is okay when two winds are going to advance towards each other, what will happen? You'll see nothing but okay what? Either warm will try to pull it or cold will nothing but okay try to pull it. As a result, okay, you see the winds moves in a which manner? In a meandering manner. Okay, they moves in which manner? Meandering manner. So it is because of the convergence of whom? Two contrasting winds. Okay, so at the upper level also there is a convergence happening of the wind, and because of this wind you see nothing but okay if the cold is advancing, then okay like this. If warm is advancing, then you'll see like this. So wind is moving in a meandering manner. Clear? So clear why the winds are moving in a meandering manner? Fine. So the contrast, okay, the contrast is more where? The contrast between converging wind is going to be more where? In this region. That's why you see more meandering. In this region, less meandering. Clear? Any doubt regarding this one? Now you remember when we discuss about meanders in rivers, We discussed when rivers are meandering and moving, what is being formed after a lower course? In lower course of a river, what is formed? In lower course of a river, what is formed? Oxbow Lake. Yes, okay. So we discussed which lakes are being formed. Oxbow Lake are being formed. How this Oxbow Lake are being formed? We discussed rivers move like this. Rivers move like this. This part of the river is being eroded. This part is being eroded over a period of time. Both this part will meet together, and wind will what? River will what? River will starts to move like this, abandoning this particular path, and this is okay. What we call as a Oxbow Lake. Okay, this we call as a. So when this path is abandoned, we call this as a Oxbow Lake. Okay, so this is how rivers started moving, taking this particular path rather than this particular path. So this we discuss as a Oxbow Lake. Clear? So when here also this is moving in a concentrated band region, this air is moving in a concentrated band region, what will happen? After a certain point of time, you see nothing but okay, air will start moving like this, leaving which particular path? Leaving nothing but okay, this particular air, leaving this particular air. So this particular air will be left out. When this particular air will be left out, what will happen? When this particular air will be left out, what will happen? This particular air will be left out, what will happen? This is the one which causing what we call as a western disturbances in India. Remember, we discussed western disturbances, the wind coming from where to where? From west towards nothing but okay, eastern part of India. Clear? So we discussed this is how the India is there. We discussed from the Mediterranean Sea, the wind are coming and which rainfall in India? Winter rainfall in India. This is called as what? This is called as a western disturbances. Why western disturbances are being created? Because you see in this region, what is moving? Jet stream are something that are moving around 30 degree. What is moving? Around 30 degree, what is moving? Subtropical jet stream are moving. This subtropical jet stream is moving in which manner? Meandering manner. And when one of the branch of this particular air will be left out, then this branch will create what? This branch will pick up the moisture and create rainfall. And this is okay, what we call as what? This we call as a western disturbances. This influences the cyclone. This influences the cyclone that is okay formed in the winter region. Fine, any doubt regarding this particular part? So this is okay, important aspect that you have to keep in mind with regard to jet stream. Fine, any doubt regarding this one? So why permanent jet stream are formed? Subtropical jet stream. Why subtropical jet stream are being formed? So we discuss subtropical jet stream are being formed because of what? Because of temperature contrast between tropics, between tropical region and temperate region. It is formed due to contrast between tropical region and temperate region. And what you see is okay, what? It is formed between Hadley cell and Ferrel cell. It is formed between who? It is formed between Hadley cell and Ferrel cell. So subtropical jet stream, how it is formed? It is formed due to temperature contrast between who? Temperature contrast between tropics region and temperate region. And what you see is okay, it forms due to contrast between whom? Contrast between the Hadley cell and Ferrel cell. Clear? Clear? So as we discussed, the wind are rising from equatorial region, subsiding in what? Subsiding in subtropical high pressure belt region. This is equatorial low pressure belt region. This is what? Subpolar low pressure belt. From here it is rising, moving like this, subsiding in this region, that is okay there. And from here to here, which wind flows? Westerlies. From here to here, which wind flows? Northeast trade wind. We call this cell as which cell? Hadley cell. We call this cell as which cell? Ferrel cell. And where do you see formation of what? Where do you see formation of jet stream? So this is the region where, okay, what is being formed? Subtropical jet stream are being formed. Okay, subtropical jet stream are being formed. So subtropical jet stream are formed between whom? These are formed because of temperature contrast that is existing between whom? The tropical region and temperate region, that is okay there, and form between which cell? Form between Hadley cell and Ferrel cell, that is okay there. Clear? Now this subtropical jet stream also have what? This will also shift. This is also shift due to shifting of what? Shifting of pressure belt. This tropical jet stream will also shift due to what? Due to shifting of pressure belt. Okay, so as we discussed, where this is being formed? Where this is being formed? Okay, between what? At the subtropical high pressure belt. Above the subtropical high pressure belt, you are seeing which wind is blowing? Subtropical jet stream. You know that subtropical high pressure belt will shift. Why it will shift? Because sun's position keeps on changing. When sun's position is at Tropic of Cancer, what will happen? Subtropical jet stream is going to be shifting upward. When, okay, what? Then when sun position is at Tropic of Capricorn, then subtropical jet stream is subtropical high pressure belt is going to be nothing but, okay, shifting downward. So this subtropical the subtropical what? Subtropical jet stream is going to nothing but, okay, shift. It is not, okay, what? It is not only fixed. It is not that it is fixed. As the things are changing, pressure belts are changing, what will happen? You'll also see shifting of this particular thing. Let's say this is, okay, what? This is nothing but, okay, India. We discussed this is 23.5. Let's say sun position is over here. Sun position is over here. Clear? Now when sun position is over here, what will happen? What will happen? Equatorial low pressure belt is going to be formed where? This is where equatorial low pressure belt is going to be formed. This is where what is going to be formed? Subtropical high pressure belt is going to be formed. It is going to shift upward. This is at equator. Clear? So when sun position is at Tropic of Cancer, what will happen? Equatorial low pressure belt will shift upward. When equatorial low pressure belt will shift upward, what will happen to subtropical high pressure belt? It will nothing but, okay, shift upward. So where the jet stream will now blow? Where the jet stream are now going to blow? Where the jet stream are now going to blow? We discuss jet stream is blowing over where? This is subtropical high pressure belt. This is where void is being created. So jet stream is blowing over where? Over nothing but, okay, subtropical high pressure belt region. So in this direction, you see jet stream are now blowing. Jet stream are blowing in this direction. Clear? In the subtropical high pressure belt, above subtropical high pressure belt, you see jet stream are nothing but, okay, going to blow. Clear? Any doubt? So the jet stream will move from where to where? From west to east direction. So they'll move like this, okay, over here. Now assume the different conditions. Now assume this is, okay, what? This is winter condition. Now sun position is where? Over here. When sun position is Tropic of Capricorn, equatorial low pressure belt now will shift over here, and subtropical high pressure belt will now shift over here. So subtropical high pressure belt, which was beyond India, will now shift downward towards nothing but, okay, India, that is okay there. So now that jet stream will blow where? Now the jet stream will blow where? Jet stream will blow like this, okay, from where to where? From west to nothing but, okay, east direction. So during winter, you are seeing jet stream are blowing over where? Jet stream are blowing over India during which season? During the winter season. During summer season, where do you see what jet stream are blowing? Summer season, they are, okay, blowing beyond India. They are blowing beyond India. Clear? During summer, what is happening? Jet stream are blowing beyond India. During winter, jet stream are blowing over India. That is okay there. Clear? Clear? Any doubt regarding this one? So as a result, subtropical jet stream influence Indian monsoon. Okay, so it will not be constant, it will be shifting, and they are going to influence which monsoon? Indian monsoon. So subtropical jet stream shift is not constant, they shift as the, okay, the pressure belt shift, and what you see is, okay, they are influencing Indian monsoon. How they are influencing Indian monsoon? How the subtropical jet stream are influencing Indian monsoon? We discussed in winter season they are blowing over what? In winter season they are blowing over India. In summer season what is happening? They are blowing above India. That is okay there. Clear? How it is influencing Indian monsoon? How it is influencing Indian monsoon? Southwest monsoon. How it is influencing southwest monsoon? But southwest monsoon blow at the surface or at the upper level? So how it will be getting mixed? See, for monsoon to occur in India, for monsoon, southwest monsoon to move towards India, what is required? Where high pressure should be formed? Here. Where low pressure should be formed? Here. At the Indian landmass, if low pressure is formed, then only wind will come from where? From the ocean towards nothing but land. Okay. So wind will only come from where to where? Wind will only come from ocean towards land when, which here at the ocean, which pressure is going to be formed? High pressure. At the land, which pressure is going to be formed? Low pressure. Clear? Any doubt? Now where when subtropical jet stream is moving, is it creating high pressure or is it creating low pressure? When subtropical jet stream is moving, it is creating high pressure or is it creating low pressure? Moving from high pressure to low pressure. We discussed where subtropical jet stream is moving. In this region, upper atmosphere. In this region it's moving. What is created at the lower region? What is created at the lower region? At the surface, which temperature is which pressure is created? High pressure. It is subtropical high pressure belt zone, no? So we discussed subtropical jet stream will move over what? Over the high pressure. So when subtropical jet stream is moving in the upper atmosphere, they are moving like this. At the surface, which pressure is being created? High pressure are being created. Which pressure is being created? High pressure are being created. If high pressure will be created at the surface, will wind move? No, at the surface wind will not come. Clear? So till the time in winter they are blowing over what? In winter they are blowing over above the India. Jet stream are blowing in winter above India. So when they are blowing above India, at India which type of pressure is going to be created? High pressure at the surface is going to be created, and when high pressure will be created, wind will not move. Like this. Clear? Unless and until jet stream withdraws from India. When jet stream will withdraw, what will happen? You see, high pressure will move from here to where? Here to here, because now jet stream is moving over here. So when jet stream will withdraw, then only here what will happen? Low pressure will be created, and you'll see wind moving from here to here region. Clear? So that's how the subtropical jet stream influences what? Influences Indian monsoon. So till the time jet stream are not withdrawing, till the time, I am just writing, till the time jet stream do not withdraws from India till the time monsoon will not arrive in India. Monsoon will not arrive in India as jet stream creates high pressure at the surface. Clear? Jet stream create which type of pressure at the surface? High pressure at the surface. Clear? So where the jet stream is blowing? We discussed jet stream blows in a upper atmosphere. When jet stream blows in upper atmosphere, at the surface, which type of pressure is going to be created? High pressure is going to be created. Unless this high pressure withdraws from India and low pressure is created, you don't see wind coming to India. So that's why monsoon does not arrive in India till the time the jet stream is not withdrawing. Clear? So that's how the jet stream influences Indian monsoon. Clear? Any doubt regarding this particular thing? So the question might come, how jet stream influence Indian monsoon. So you have to explain which type of jet stream over here. subtropical jet stream, and you have to state that till the time subtropical jet stream is over India, which type of pressure is over India? High pressure is there. That's why wind doesn't arrive towards India. When jet stream withdraws, then what will happen? Which type of pressure is created? Low pressure is created. So this allows the wind to come towards nothing but India. Fine. Till the time jet stream do not withdraws from India, monsoon will not arrive in India. Just as jet stream create high pressure at the surface. Monsoon will not arrive in India at jet stream create high pressure at the surface. Fine. So just remember this particular part, that in the winter jet stream is over here. In the summer jet stream withdraws from India. So sometimes, you hear monsoon arrive on time in India. Sometimes you see monsoon arrive late in India. When monsoon will arrive late in India? When the jet stream is not withdrawing. When jet stream will not withdraw, what will happen? Monsoon will arrive late in India. So generally jet stream withdraws in the month of May. In the month of May, you generally see withdrawal of jet stream from here to here. Why? Because by the time May comes, you see sun is moving towards where to where? Sun is moving from equator towards where? Towards the Tropic of Cancer region. When sun comes more closer to the Tropic of Cancer, what will happen? You know that sun reaches Tropic of Cancer at which time? 21st June. So in May month, sun is over somewhere here. When May months, this region will receive huge amount of sunlight. When this region will receive huge amount of sunlight, what will happen? Low pressure starts to create over here and jet stream starts to withdraws from India. Clear? So that's why jet stream generally withdraws in the month of what? In the month of May region. Clear? Clear? So if there is a late withdrawal of jet stream, you will see late arrival of nothing but Indian monsoon. If you see early withdrawal of jet stream, you will see early withdrawal, onset of Indian monsoon. Clear? Any doubt regarding this particular thing? So this is an important thing you have to keep in mind with regard to how jet stream, subtropical jet stream influences Indian monsoonal system. Fine. So what you have to keep in mind? Subtropical jet stream developed because of temperature contrast between whom to whom? Tropical region and temperate region. Formed between which cell and which cell? Hadley cell and Ferrel cell. Blows in which atmosphere? Blows in upper atmosphere. So when it blows in upper atmosphere at lower, which type of pressure is being created? High pressure is being created. So when jet stream blows in India over winter, here high pressure at the surface is being created. When it withdraws from India, what is being created? Low pressure is being created, and that's how allows the onset of Indian monsoon. Clear? Any doubt regarding this particular thing? So that's why we say Indian monsoon has what? Indian monsoon is sudden arrival. When you discuss the characteristic of Indian monsoon, we discuss that Indian monsoon having sudden arrival. Why sudden arrival? Because jet stream withdraws suddenly. When jet stream withdraws suddenly, what will happen? Low pressure is suddenly created, and you'll see nothing but what? You'll see monsoon onset is sudden in India. Clear? Gradual onset is not there. They might ask you Indian monsoon, what is the characteristic of Indian monsoon? So gradual onset is not there. Indian monsoon arrival is what? Sudden in nature, because suddenly jet stream withdraws because of excessive heating, and when they suddenly withdraws, suddenly the winds starts to come over here. So sudden onset of Indian monsoon is there. Clear? Any doubt regarding this particular part? So remember that subtropical jet stream is affecting which type of monsoon? It is affecting nothing but Indian monsoon. That is there. Clear? Yeah, this is low. This is high pressure.
Then if they amount to the high pressure. Then it should come to low pressure.
No, this from here to here, wind is moving from where to where? High pressure to low pressure. Now, if this, assume this is at the upper atmosphere and this is nothing but lower atmosphere. Clear? Now at the upper atmosphere, which pressure is found? Low pressure. Low pressure means what will happen? Wind will expand. So wind is going to contract where? Down. So down, what will happen? Compression will happen. When compression will happen, what will happen? High pressure is going to be created. No?
Then jet streams are low pressure.
Jet stream are?
Low pressure.
No, jet stream are not low pressure. Jet stream are basically what? Jet stream are created in this region. In this region they are created. Why? Because as we discussed, winds are sinking down. When wind sinks down, what will happen here? void is created, and because of void what will happen, deflection will happen. This some of this wind will be deflected, okay, and move in this direction. So that deflection, because void is being created, winds are being deflected in this direction. So in this direction jet stream are moving like this.
In the monsoon time,
Hmm.
polar
In the winter, what is happening? High pressure belt is over here. Subtropical high pressure belt is here. When subtropical high pressure belt is here, what will happen to jet stream? Jet stream is also over India. Jet stream is also over India. Fine. Now, when the sun reaches to Tropic of Cancer, what will happen? Now you see subtropical high pressure belt is shifting upward. When subtropical high pressure belt is shifting upward, what will happen to jet stream? They will also shift nothing but okay upward. So when jet stream withdraws, what is going to be created? Low pressure. So that's how wind will arrive in case of wind. Fine. So this is how, okay, you see formation of nothing but okay subtropical jet stream. Fine. The second type of jet stream we have written is which jet stream? Polar jet stream. Second type of jet stream we have written which jet stream? Polar jet stream. So polar jet stream is created where? Created at created between ferrule cell and polar cell, and it is created due to temperature contrast between the temperate region and polar region. Clear? So it is created between which two cells? Ferrule cell and polar cell. So here, from here, what is happening? Subtropical high pressure belt. From here, which belt is there? Subpolar. This is subpolar low pressure belt. This is subtropical high pressure belt. And this is nothing but okay what? This is your polar high pressure belt. Okay, so like this, okay, you are seeing. So here, which cell is there? Polar cell is there. Which cell is there? Ferrule cell is there. So at here, what is happening? Void is being created. At here, void is being created. So here you'll see which type of jet stream? Polar jet stream. Here you will see which type of jet stream? Polar jet stream. Clear? Now the polar jet stream influences which type of cyclone? Temperate cyclones. Polar jet stream influences which type of cyclones? Temperate cyclones. Clear? Fine. So as we discussed here, which wind is coming? Here which wind is coming? Westerlies. Here which is coming? Easterlies. You know that we have discussed this front, warm front, westerlies coming like this, cold front, easterlies sinking like this. Okay, what is going to be created? Fronts are going to be created. So if jet stream are going to blow in this region, jet stream are blowing in upper atmosphere, and in lower atmosphere this meeting is happening. This meeting of okay westerlies and easterlies are happening in which atmosphere? Lower atmosphere. In higher atmosphere, what is moving? In higher atmosphere, what is moving? Polar jet stream. So in lower atmosphere, meeting is happening. In higher atmosphere, what is happening? Jet stream are something that are blowing. That's why jet stream influences which cyclones? Temperate cyclones. Okay, they influences temperate cyclone. Again, polar jet stream moves in more meandering fashion. It is moving in more meandering fashion. Why it moves in more meandering fashion? We discussed more meandering. Why it moves in more meandering? Because of more temperature contrast. Okay, it is moving in more meandering fashion. Why more meandering fashion? Because of nothing but okay high temperature contrast. Fine. And again, the jet stream, polar jet stream will also shift. Shifting of jet stream occur due to shifting of pressure belt. shifting of jet stream occurs due to shifting of what? Shifting of pressure belt. Fine. Clear? So polar jet stream is going to influence which cyclone? Temperate cyclone. Polar jet stream moves in a more meandering fashion. Why it moves in a more meandering fashion? Because contrast is something that is okay, very high. Okay, and polar jet stream also shift due to what? Shift due to nothing but okay, the shifting of pressure belt. So in case of summer, polar jet stream will be over here. But in case of winter, polar jet stream will be much lower than this region, because pressure belt will shift towards lower side. During winter, here you'll find polar jet stream. During summer, you'll find here polar jet stream. Fine. So shifting of pressure belt, you will see shifting of jet stream also. Clear? So if questions like this, which statement is correct? First is correct. During winter, subtropical jet stream. STJS means subtropical jet stream. Which one? Second option, summer. Okay. So the first says what? The subtropical jet stream withdrawal from India led to arrival of monsoon in India. We discussed which this statement is very much correct, because when jet stream withdraws, then only low pressure is being created, and you see arrival of nothing but okay, monsoonal wind. Second, during winter, subtropical jet stream influences the temperate cyclone. We discussed which influences the temperate cyclone. Polar jet stream, not subtropical jet stream. Which stream okay influences the temperate cyclone? Polar jet stream, not subtropical jet stream influences the. So we discussed when winter will be there, what will happen? Polar jet stream will come down and subtropical jet stream will further go down. That is okay there. Clear? So which influences the temperate cyclone? It is a polar jet stream, not the subtropical jet stream. That's why second statement is what? Wrong statement. First is what? Correct statement. Like this question can be formed in the case of examinations. Fine. Any doubt regarding this particular part? Subtropical jet stream is also going to, that is tropical cyclone, not temperate. Okay, this is writing about which cyclone? Temperate cyclone. No? So here which is influencing the temperate cyclone? Polar jet stream is influencing temperate cyclone. So here what should be there? Polar jet stream influences the temperate cyclone. Fine. Any doubt regarding this one? is all about your permanent jet stream. That is polar jet stream and subtropical jet stream are referred as what? Permanent jet stream. Fine. Have a break and then we'll continue. Fine, fine, no issues. Fine. So next we'll start with the temporary jet stream. So next we have a temporary jet stream. Temporary jet stream are further of two types. One is the tropical easterly jet stream, and the second that you have is Somalian jet stream. So first we'll discuss what? First we'll discuss the tropical easterly jet stream. Tropical easterly jet stream. Fine. Now, just now we discussed what happens during the summer month. What happens during the summer month? You see, sun reaches where? Sun reaches as Tropic of Cancer, and as a result, jet stream withdraws from where? As a result, jet stream withdraws from where? Jet stream withdraws from India. Clear? So we discussed jet stream now moves in a upper atmosphere above India in the month of summer, and this leads to arrival of whom? This leads to arrival of monsoon in India. Clear? Now, here what is formed is what? Here what is formed is a low pressure. Here what is formed is a high pressure. Clear? This led to arrival of monsoon in case of India. Fine. Now, jet stream that is moving over here moves in which fashion? Meandering fashion. So they are moving in which fashion? Meandering fashion. Now we discuss with the meandering fashion, after a certain point of time, wind will start move like this and starts to leave which part? Start to leave this air. Clear? Because of meandering, we discussed this particular air is what? This particular air is let off and wind starts to move like this. That is okay there. Clear? Now this particular air which is now let off, over here. Now this forms your what? This forms your nothing but the temporary jet stream. This forms your temporary jet stream, and it is referred as what? It is referred as a tropical easterly jet stream. It is referred as a tropical easterly jet stream. Fine. Any doubt regarding this one? So what will happen is what will happen is, as we discussed, during the monsoon time, this region, this entire region, Tibetan Plateau region, is going to be heated, and as a result, which pressure is being formed? Low pressure is being formed. From here, the wind will starts to come like this, from high pressure to low pressure. Now this movement is happening at the surface. This is high pressure and this is low pressure. This movement is happening at the surface. But low pressure is what will happen here? Low pressure means what will happen here? Air will rise up. So air starts to rise up from nothing but the Tibetan Plateau. Air will starts to rise up from which plateau? From Tibetan Plateau, that is there. And in the upper atmosphere, what is moving? What is moving? Jet streams are something that are moving. In the upper atmosphere, what is moving? Jet stream are something that are moving. Jet stream is leaving which part? jet stream leaving nothing but okay this particular part, that is okay there, and as a result this particular part will be influenced to move towards nothing but okay this side. So now the wind will rise up this part, this particular part. From here what you see is okay, wind is rising up, moving in this direction and subsiding where? Subsiding in the case of nothing but okay this particular region. So wind is rising from where? Wind is rising from Tibetan Plateau, moving in this direction and then subsiding in which ocean? Indian Ocean region, that is okay there. So when wind subside over here, then what will happen? So let's say the wind is rising from Tibetan Plateau, moving into upper atmosphere, subsiding in this region. So this is Tibetan Plateau, this is Indian Ocean region. When wind subside in Indian Ocean region, what will happen? Which pressure is going to be formed? High pressure. When wind is rising from here, what is being formed? Low pressure is being formed. So this tropical easterly jet stream strengthened the high pressure. It is strengthened the high pressure in Indian Ocean region. As a result, more wind will blow from where? Go from where to where? From high pressure towards low pressure. And that's why this also strengthen whom? This also strengthen Indian monsoon. This also strengthened which monsoon? This also strengthened Indian monsoon. So tropical easterly jet stream also strengthened Indian monsoon. Why it strengthened Indian monsoon? Because the wind is rising from where? Wind is rising from Tibetan Plateau region. When it is rising from Tibetan Plateau, it is subsiding where? Subsiding where? So wind is rising from where? Wind is rising from Tibetan Plateau, moving like this and subsiding where? In the Indian Ocean region. So assume this is a Tibetan Plateau. Wind is rising like this, moving like this, subsiding where? Subsiding in the case of Indian Ocean region. Thus strengthening what? That's strengthening the high pressure. And more high pressure means what? More wind will come towards nothing but okay India, that is okay there. So even tropical easterly jet stream what? Tropical easterly jet stream strengthen the monsoon in case of India. Clear? Any doubt regarding this one? When this type of jet stream forms, they strengthen the monsoon in case of India. Clear? So what you have to keep in mind is these are temporary jet stream. These are temporary jet stream. Develops during summer. Develops during summer, strengthen monsoon in India. Strengthen monsoon in India. These are temporary jet stream, develops during summer, strengthen monsoon in India. Fine. Why it is called as a easterly jet stream? Why it is called as a easterly jet stream? Because generally we discuss westerlies, the jet stream move from where to where? From west to east direction, but it is moving from where? It is moving from east side to nothing but okay west side, and that's why it is called as a which type of jet stream? Easterly jet stream. Okay, so it is easterly jet stream. Clear? This tropical easterly jet stream are phenomena generally found between this latitude 5 to 20 degree northern latitude. This phenomena is generally seen in 5 to 20 degree northern latitude. Clear? Right. During summer, the secondary circulation strengthen high pressure in Indian Ocean region. High pressure in Indian Ocean region. High pressure in Indian Ocean region, leading to more arrival of southwest monsoonal wind in India. Monsoonal wind in India. Clear? So during summer, the secondary circulation leads to what? The secondary circulation lead to high pressure strengthening in which region? In Indian Ocean region. High pressure is strengthened in Indian Ocean region, leading to arrival of whom? more arrival of southwest monsoonal wind in India. Leading to more arrival of southwest monsoonal wind in India. Clear? Now another jet stream that is okay formed during this period is Somali jet stream. Clear? Another that is okay being formed is a Somali jet stream that is okay there. Clear? So what this Somali jet stream is all about? Fine. So what you see is okay. What you see is okay during the monsoon season only. We discussed it is okay which Somali jet stream. Now during during July to September, you'll also see formation of this wind, which is called as a Somali jet stream. Now what happens is Somali jet stream is from here, from the Somali region. From here, this is okay Madagascar. This is where you'll find nothing but okay Somalia. This is okay where you'll find Somalia region. So just above this Somalia region, you will see the wind will starts to rise up. Wind will start to rise up, move like this and subside over here. Clear? So wind starts to rise up from here. I'm just making this, move in this and start to subside over which region? Start to subside over Arabian Sea region. They start to subside over which region? Arabian Sea. So wind rising from here, moving in this direction and subsiding over here. Which region? Arabian Sea region. So when wind subside over Arabian Sea region will be forming high pressure. When wind will subside, which pressure will be forming? High pressure is going to be formed. And wind is rising from where? Wind is rising from here. Wind is rising like this, moving like this, and then subsiding in which region? Arabian Sea region. In upper atmosphere, the wind is moving. So like this, it is rising, then moving in this region, and then subsiding nothing but okay like this. Clear? Any doubt regarding this one? So again, it is creating which type of pressure? High pressure. More high pressure means what? More monsoon arrival where? In the India. So even Somali jet stream is something that is strengthening whom? Strengthening Indian monsoon. Indian monsoon. It is more of a southwesterly wind blowing in tropospheric region. Blowing in tropospheric region. So it's strengthened monsoon. It is a southwesterly wind. From where to where it is moving? Like this. So southwest means what? Southwest is like this. So this is south, this is west. So originating from where to where? It is originating from Somalia, moving towards where? Moving towards something but okay, this direction, subsiding over here. So this is your okay, what? Indian Ocean, this is Arabian Sea. And this is where India is something that is okay there. So it is moving in upper atmosphere from where to where? From nothing but okay, Indian Ocean, this particular part, towards nothing but okay, Arabian Sea part, okay, that is okay there. Clear? Any doubt regarding this one? So this again strengthen whom? Strengthen Indian monsoon blowing in upper tropospheric region, causes high pressure formation, over Arabian Sea region, leading to leading to more monsoonal rainfall, causes high pressure formation over Arabian Sea region, leading to more monsoonal rainfall in India. Leading to more monsoonal rainfall in India. Our atmosphere. From here it will rise. Let's say from here it will rise like this. Okay, then will move like this, upper atmosphere, then subside like this in where? In the Arabian Sea region. So that's why southwesterly we have written. Rising like this, moving in this direction, subsiding in what? Arabian Sea region. So southwesterly direction. Right? Fine. So this is all about what? This is all about your the permanent jet stream as well as, okay, which type of jet stream? Temporary jet stream. So what is jet stream? Jet stream are blowing in which atmosphere? Upper atmosphere. They are moving in which direction? West to east direction. Which type of wind it is there? Circumpolar wind, geostropic wind, Rossby waves. So those terms, okay, you have to keep in mind with regard to stream. We discussed jet stream are divided into what? Two types. One is permanent jet stream, another is temporary jet stream. Permanent jet stream are your subtropical jet stream and polar jet stream. Temporary jet stream that develops, okay, due to secondary circulation. It is creating which type of jet stream? Somali jet stream and tropical easterly jet stream. Both these stream strengthen monsoon in India. So now, if you remember, now what are the factors we have discussed that influences monsoon in India? If you remember, we discussed El Nino is what? Influencing monsoon in India. We discussed La Nina is influencing what? Monsoon in India. We discussed IOD, Indian Ocean Dipole, is influencing what? Monsoon in India. We discussed subtropical jet stream. Its withdrawal will only lead to what? Arrival of monsoon in India. Then we discuss also what? The Somalian jet stream and tropical easterly jet stream. Somalian jet stream, all are influencing monsoon in case of India. All phenomena are influencing monsoon in India. That's why we discuss monsoon in India is very complex phenomena. Clear? Sometimes, okay, you see the IMD, Indian Meteorological Department, talks about that, okay, monsoon will be normal, and monsoon doesn't, okay, becomes normal in India. Why? Because if any of these factors is not properly studied, not properly predicted, then it may lead to what? It may lead to affecting the Indian monsoon system. Fine. So this is, okay, important aspect you have to keep in mind. All these factor influences monsoon in India. Fine. So if the question comes in the mains examination, what are the factors affecting Indian monsoon? You have to talk about what? Briefly, you have to explain all these factors, that these are the factors influencing the Indian monsoon. Fine. Now, next is what is the relevance of jet stream? What is importance of jet stream? The first importance is it helps in maintaining latitudinal heat balance. Latitudinal heat balance. That is the most important thing jet stream is doing. Jet stream is, okay, helping in what? Helping in maintaining a latitudinal heat balance. We discussed from where jet stream are from where? It is formed between which cells? Like we discussed, polar cell and like equatorial low pressure belt and subtropical high pressure belt. So this belt is referred as what? This belt is referred as a Hadley cell. Then we discuss this belt is referred as what? Ferrel cell. So what you see is, okay, which region is more heated? Equatorial low pressure belt is more heated. Where the jet stream are formed? Here the jet stream are formed. Why jet stream are formed? Because the heat is being taken from here to what? Heat is being taken from here to nothing but, okay, tropics region. Okay, heat is being taken from here to tropics region. That is, okay, there. So it helps in maintaining what? It helps in maintaining the latitudinal heat balance. More heat from equator is being transferred to where? More heat from the equator is being transferred to the Tropics. More cold from the polar region is being brought towards what? Tropic. As a result, it leads to moderation in climate. Moderation, neither too hot nor too cold condition. Moderation in climate is being brought. So it maintains latitudinal heat balance. Just now discussed, jet stream affects what? This affects the weather pattern. We discussed jet stream affects weather pattern. Just now we discussed if jet stream are formed over India, high pressure is there. High pressure means what? No rainfall will happen. Clear? So jet stream affects what? Jet stream affects the weather. We discussed when jet stream are over India, what will happen? Jet stream are over India, blowing over India. What is formed over India? High pressure. High pressure means what? No rainfall is going to happen over India. So jet stream is affecting your weather pattern. Clear? Third thing, jet stream influences what? Influences the path, intensity, speed of temperate cyclones. Speed of temperate cyclone. Jet stream are influencing the path, the speed, as well as nothing but intensity of the temperate cyclones. Temperate cyclones. It also affects Indian monsoon formations. Indian monsoon formations. Indian monsoon formations. It also impacts Indian monsoon formations. Fine. So the drought and flood can be decided by whom? Drought and flood can be decided by the jet stream because it's affecting the Indian monsoon. So it decides the drought as well as flood conditions. Fine. Clear? So we can say that jet stream are influencing whom? Jet stream are influencing the air masses. Air masses leading to flood or drought conditions. Drought conditions. Jet stream are influencing the air masses leading to what? Leading to the flood or drought conditions. Fine. And the last thing, jet stream also helps in movement of whom? Jet stream also helps in movement of flights. Jet stream also helps in what? Movement of flights. So these are these are importance of jet stream. Clear? If question come, what is jet stream? What are the importance of jet stream? Why you have to study jet stream phenomena? You have to write about these particular point. That it helps in maintaining latitudinal heat balance, affects weather pattern, affects air masses, and decides flood and drought condition, influences the path, intensity, and speed of temperate cyclone. Also affect Indian monsoon formation, and jet stream also helps in flight movement. Clear? Any doubt regarding this one? If you see this, you can see this particular region. This is a flight radar data that you are finding. Why you are finding more concentration of things in this region? You can see more concentration of things is happening in this particular region. Why do you see? Why do you see more concentration of flights movement in this particular region? Because this is the reason where you see jet stream or something that are blowing. When jet stream blows, let's say flight has to move from here to here, what will happen? they will, okay, what, they will move with the jet stream, because when jet stream will move like this, if the flight is there, flight will be aided by movement of whom? Movement of wind. Flight will be aided by whom? Movement of wind. Okay, flight can easily move from one direction to another direction. You know that when you are moving against the wind, what will happen? Okay, you'll see, okay, more force is required, more fuel will be, okay, required. When, okay, what will happen when you are moving in the direction of the wind? When, then what will happen? Less fuel, less things are required. That's why when the flights are coming from there to here, what will happen? They always take the jet stream path. Okay, why they take this jet stream path? Because it allows, okay, easier movement, high velocity movement from one point to another point. So that is what happens with the jet stream. That's why when you see from here to here, when flights are coming, let's say, you'll see movement, you'll take the flight distance, let's say from here to here, from India, if you're moving towards what, if you're moving to this particular region, that is European region, let's say flight is taking 8 hours while going, while coming it will take around 7 hours itself. Why? Because, okay, when you are going against the jet stream, but when you are coming, what will happen? You are coming with the jet stream. When you are coming from here, what will happen? You can move with the jet stream, that is okay there. But when you are going against, you are moving against nothing but, okay, jet stream. So then when you are moving against jet stream, then what will happen? More longer duration. When you are coming with the jet stream, what will happen? Easier movement. So this is how we see the movement is impacted by whom? Movement is impacted by the jet stream. Clear? So that's why most of the flight, when they are moving from west to east, they always take the jet stream path so that they can easily move from one location to another locations. Fine. So these are all about jet stream that you have to keep in mind. They will be throughout. Permanent jet stream are throughout the year. We have written permanent and temporary. Permanent means what? Throughout the year. Temporary means what? Only formed for a certain period. So permanent stream are going to be throughout the year, because we discussed why they are formed. Due to circulation. This circulation is throughout the year. No? Ferrel cell, Hadley cell. We discussed pressure belt are permanent. They are present throughout the year. So when pressure belt are permanent, okay, the jet stream that is going to be formed is also throughout the year. Fine. So this finishes your, okay, what? This finishes your jet stream, and this finishes also your climatology part. But there are two news. There are two news which we have to cover, because that is related with the climate. More coming, but the term is coming in the examination. You will get that question in the case of examination. So one is a concept of polar vortex. One is a concept of polar vortex that you are getting. This is something that you are finding. A lot of, okay, news is coming regarding polar vortex. So you can see this is a, okay, one day back news. It is saying La Nina and polar vortex shapes a cold surprise ahead. What is being coming? Polar vortex. You see trend and anomalies in the polar vortex. US facing ice age. Polar vortex changes sending northern hemisphere into deep freeze. So this term is coming regularly in news. UPSC can pick up these type of questions in the case of examination to explain. Clear? So just this, keep in this mind the term polar vortex, because it is a current affairs. Okay, you are getting a lot of news. Okay, like you can see the Indian Express covering, Economic Times covering, all newspaper are covering this concept of polar vortex. Clear? So what is this particular polar vortex? So this is what, okay, you are finding with regard to polar vortex. Clear? You can see there are two type of polar vortex. One is a strong polar vortex, another is nothing but, okay, weak polar vortex. So you can see this is a weak, this is nothing but, okay, strong one. Okay, strong polar vortex as well as nothing but, okay, weak polar vortex. What is this polar vortex? So polar vortex can be defined as what? It can be defined as a rotating wind in upper atmosphere, or you can write spinning wind also. Spinning wind or rotating wind in upper atmosphere in polar regions. So it is which type of wind? It is rotating wind or spinning wind in upper atmosphere in which type of region? In polar region. Clear? So this is a polar region. Above the polar region, you see this, above the polar region, wind is something that is spinning like this. Okay, wind is something that is spinning like this, and this is what we call as a rotating wind or spinning wind in the case of upper atmosphere. Fine. Why this wind is being created? Why this wind is being created? So we just now discussed what is happening from subpolar low pressure belt. This is your subpolar low pressure belt. So wind will rise like this. Then we discuss one branch will move towards what? Subtropical high pressure belt, and one branch will move towards what? Towards something but polar high pressure belt. Fine. This is what we have discussed. So this cell is referred as what? Which wind is flowing from here to here? Westerlies. Which wind is coming from here to here? Easterlies. We discuss which cell is here. Which cell is here? Polar. This is ferrule cell. This cell is which polar cell? Clear? When wind is rising, wind is moving in this direction. When this wind is moving, what will happen? When wind is moving in upper atmosphere, we discuss what is happening when wind is moving in upper atmosphere. It is under the influence of. It is under the influence of whom? Two forces. What are the two forces? Pressure gradient force and Coriolis force. Okay, so it is under the influence of two forces. So this particular thing is under the influence of two forces. Because of the Coriolis force, they will be deflected. What? They will be deflected from their path. So this wind is being deflected, and when this wind is deflected, it is creating what? It is creating a spinning things. Okay, as we discussed, Coriolis force will increase from where to where? From equator towards something but polar region. When you are moving from equator to polar region, what will happen to Coriolis force? Increase. So what you see is wind that is moving like this is deflected much. It is deflected much, and it is creating which type of wind? It is creating a spinning wind. Okay, it is creating which type of wind? It is creating a spinning wind. Okay, so you know that Coriolis force is generated because of what? Coriolis force is generated because of what? Rotation of Earth. Earth rotation creates which type of forces? Coriolis force. Okay, so Coriolis force generated due to rotation of Earth. Generated due to rotation of Earth. Rotation of Earth causes high deflection. Causes high deflection in upper atmosphere. Causes high deflection in upper atmosphere, leading to creation of spinning or rotating wind. Leading to creation of spinning or rotating wind, which is called as what? Which is called as a polar vortex. This is referred as a polar vortex. This is called as a polar vortex. Clear? Now, if you remember last class, we talked about which wind is which is a gusty wind blowing in Arctic region in USA, Canada. Which local wind discussed? Gusty wind is blowing in this region. Which local wind is blowing in Siberian region? We discussed last class. We discussed Siberian type of climate, no? Or taiga type of climate. Which wind is blowing in this region? Local wind. Which cold local wind is blowing in Siberian region? We talked about what? We talked about blizzard. Blizzard we have discussed. It is a cold local wind blowing in what? Blowing in Siberian region as well as nothing but USA and Canada region. Clear? So when blizzard comes, what happens? When blizzard comes, what happens? We discuss snowfall. Snowfall happens in case of what? Excessive snowfall happens in the case of nothing but USA, Canada. Excessive snowfall happens in case of USA, Canada. Excessive snowfall also happens in case of what? In the case of Russia, Siberian region. Clear? So that we have discussed, no? So why this blizzard is coming? Blizzard is coming Now, what you have to keep in mind is which type of wind is going to be there. It is going to be low pressure wind. Why low pressure wind? Which type of wind? Polar vortex is okay. Which type of wind? We have written rotating wind in upper atmosphere in polar region, but it is which type of wind? Low pressure wind. Why low pressure wind? Because we discuss here is low pressure and here is what? High pressure. Wind will subside at the high pressure. So at the upper atmosphere, what will happen? Low pressure. At the lower atmosphere, what will happen? High pressure is going to be formed. So since this is created in upper atmosphere, this spinning is created in upper atmosphere, it is which kind of pressure wind? It is a low pressure wind. Okay, so that also you have to keep in mind, that polar vortex is a low pressure wind. It is a low pressure wind that is spinning in the upper atmosphere. Fine, any doubt regarding this particular thing? So when you see shifting of pressure belt happens, when this pressure belt shift, earlier subpolar low pressure belt is here. When this subpolar low pressure belt will shift, what will happen? So we discussed during winter, what will happen to subpolar low pressure belt? When sun position is over here, subpolar low pressure belt will shift downward, and polar high pressure belt will be what? Will also shift downward. Okay, so when polar high pressure belt will expand, subpolar low pressure belt is going to shift downward. What will happen to this spinning wind? What will happen to this spinning wind which is generated? It is going to cover much larger area. Why it is going to cover much larger area? Because these are now taking much larger area. This pressure belt are now taking much larger area. Clear? Earlier during what? During when sun position was at Tropic of Cancer, you see this was polar high pressure belt and this was nothing but okay subpolar low pressure belt. Clear? They were occupying lesser area, but now they are occupying what? More area because of okay shifting of pressure belt. Clear? Any doubt regarding this particular thing? So when the pressure belt will shift, when pressure belt will shift towards okay what? Towards nothing but okay south, you see this polar vortex will occupy more region. It will occupy more region. So the cold wind, this is a cold wind. Now this cold wind is coming towards nothing but okay southern side. This cold wind is coming towards southern side. When this cold wind will come towards southern side, what it will cause? What it will cause? Cold wave condition. Which type of okay wind is going to be there in upper atmosphere? Cold wind is going to be there. When this cold wind is going towards nothing but okay what? This wind is expanding. When this wind is expanding, what will happen? What will happen? You're not getting. I'll start this. Fine. Let's say this is okay what? Assume this is your subpolar low pressure belt region. Now assume this will now become your subpolar low pressure belt region. Shifting of pressure belt will occur, no? So assume this is now becoming your subpolar low pressure belt region. So subpolar low pressure belt is shifting southward. When it will shift southward, what will happen to this wind? This will also expand, no? This spinning will also expand. So when this spinning will also expand, what will happen? Cold wave will also expand. The cold wave will also expand. Here you see this spinning wind. This spinning wind in the upper atmosphere is the reason for what? Subsiding wind. Okay, that is okay there. Clear? In the polar high pressure belt region. Fine. So when the spinning will be more, what will happen? You see colder okay wind will come more towards nothing but okay ground side. When colder wind will come more towards ground side, what will happen? What will happen? You will see more cold wave condition at the ground. Which type of condition will happen? Cold wave condition you are going to found on the earth's surface, on the ground, like USA, Canada. So we discussed okay here what is there? Russia is there. Here what is there? Norway, Sweden. All these feel what? All these feel nothing but okay more amount of cold wave. All these will feel more amount of nothing but okay cold wave. So this is okay happening due to which region? This is happening due to polar vortex region. Okay, this is happening due to polar vortex concept. Clear? Any doubt? So what is a polar vortex? If question comes, what is polar vortex? It is a low pressure wind blowing, spinning where? Spinning in the polar region above the in the upper tropospheric region. Okay, not in lower tropospheric. It is spinning where? It is spinning in the upper tropospheric region. Fine. And due to shifting of pressure belt, what will happen? This polar vortex will expand, wind will expand, And when this spinning wind will expand, what will happen? It will cause more cold wave conditions in case of nothing but okay, USA, America, and other region. Fine? Any doubt? So that is the reason why you see when you see this news. So you can see this is a figure it is showing. Where the wind are spinning in upper atmosphere. Where the wind are spinning, it are spinning in upper atmosphere. What is happening at the surface? More okay, what more cold wave conditions? Okay, you are finding more cold wave, more ice. You are finding more cold wave conditions. You are finding. So this is okay. What it is written? The vortex, a low pressure zone. We discussed polar vortex is which type of zone? Low pressure zone over the Arctic region. Over the Arctic region, it is found where? In the polar region. It is found where? In the polar region. So Arctic region, you are finding this polar vortex, and it is okay. It is saying here what? So when the polar vortex is expanding, what is happening? You see extreme cold and severe winter weather, heavy snowstorm. Clear? You are finding extreme cold conditions, severe winter, more what? More snowstorm. More snow is something that is okay being occurring where in US, in Canada, leading to loss of life also. It is leading to more loss of life also. It is leading to nothing but okay, more loss of life also. Fine. So this is okay, important aspect you have to keep in mind with regard to polar vortex. Question might come. Even regarding this one, you can see this one. Winter 2025 early forecast, La Nina and polar vortex shapes a cloud surprise ahead. Okay. So if question come, what is polar vortex? What you're gonna write? It is a low pressure wind blowing, spinning where? Spinning in the polar region in the upper atmosphere, and due to shifting of pressure belt, what is happening? Okay, you see expansion of this spinning wind. When expansion of this spinning wind will happen, what will happen? It will cause excessive cold condition where? Excessive cold condition where? In the US, in Canada, in Russia, excessive cold condition in Norway, Sweden, you'll see excessive cold condition is going to be there. So this is what we call as what? This is what we call the concept of polar vortex. Fine. Another important thing that you have to keep in mind is, another news that you are finding is, polar vortex, right on. It is a low pressure. It is a low pressure spinning wind. It is a low pressure spinning wind in the upper atmosphere. In the upper atmosphere, in the polar region, in the polar region, more prominent over Arctic region. In the polar region, more prominent over Arctic region, which causes severe cold wave conditions, in USA, Canada, in USA, Canada, in Siberian region of Russia, and also in Scandinavian nations. Fine. So this is all about what? This is all about the polar vortex concept. Now, The next news, okay, that you are constantly finding is regarding this oscillation, Madden-Julian oscillation. Okay, so in examination, this can also come. What do you understand by the term Madden-Julian oscillations? Fine. So another news that you are getting constantly is with regard to this oscillation, which is called as a Madden-Julian oscillations. Fine. What is this oscillation? If you see the news, you can see this is 28th May 2025 news. Okay, how the Madden-Julian oscillation helps trigger the early onset of monsoon. You can see 3 weeks, okay, before news, how Madden-Julian oscillation is talking about things. So again, one thing that you are constantly getting in news is this concept, which is Madden-Julian oscillations. Fine. Any doubt regarding this part? So what you have to keep in mind is what here you know that during summer what will happen? During summer what will happen? You see sun position shift towards where? Tropic of Cancer. During summer what will happen? Some position shift towards Tropic of Cancer. When sun position shift towards Tropic of Cancer, what will happen? Which area is going to be more heated? We discussed this area, equatorial low pressure belt will shift upward, and you will see this area is going to get more heated. Clear? When this area is going to get more heated, what will happen? You know that any area, any surface, when it is heated, what will happen? Air will what? Air will nothing but, okay, rise up. Clear? When area is heated, air is going to be rising up. So that is what is happening over here. Because of heating of area, you see air is something that is, okay, rising up. Clear? Now, when this entire column of air, which is rising up, when this entire column of air shift from here to here, okay, shift from here to here, when this entire column of air shift from here to here, that is which type of movement? Eastward movement. This is called as what? This is called as a Madden-Julian oscillation. Clear? So Madden-Julian oscillation is what? It is a vertical column when there is a eastward movement of vertical column of air or cell from Indian Ocean region to the Pacific Ocean region. So Indian Ocean region to the Pacific Ocean region, this is referred as Madden-Julian oscillation. This is referred as Madden-Julian oscillations. Fine. This is referred as which type of oscillation? Madden-Julian oscillation. So eastward movement of vertical column of air or cell from Indian Ocean to the Pacific Ocean region. This is referred as what? This is referred as a Madden-Julian oscillations. Fine. Now you are seeing when air is rising up, what will happen? Air will diverge. So what is happening over here? Air is nothing but, okay, diverging. You can see from here air is rising, and what is happening? Air is now diverging. This divergent air is subsiding where? This divergent air is subsiding where? In the Pacific Ocean. So this side is which ocean? Indian Ocean. Australian, you see this is Australia. Australia, this side is which ocean? Indian Ocean. Australia, this side is which ocean? Pacific Ocean. So this is, okay, rising over here. This is nothing but, okay, subsiding over here. So which pressure is being created over here? Low pressure. Which pressure is being created over here? High pressure. This is also called as a convective phase. Convective phase will create rainfall, because low pressure, you know that when air rises, what it happens? It create a rainfall, and this is called as a suppressive phase. This is referred as a suppressive phase, and this will not create rainfall. Not create rainfall. Why? Because subsiding air do not create any rainfall. So in this Madden-Julian oscillation, what you are finding is there are air is rising, moving this side and subsiding this particular side. So you can also see this Madden-Julian oscillation is which type of phenomena? As we discussed, atmospheric ocean coupled phenomena. It is which type of phenomena? Atmospheric ocean coupled phenomena. From oceans winds are rising, and where they are rising? In the atmosphere. So this is also being defined as which type of phenomena? Atmospheric ocean coupled phenomena. Fine. Fine. So what you have to keep in mind is Madden-Julian oscillation is what? Atmospheric ocean coupled phenomena. What happens in this phenomena? The column of air or cell from Indian Ocean region moves towards where? Move towards in the Pacific Ocean. Clear? It moves towards Pacific Ocean. Normally, this particular entire movement of column of air from here to here, okay, from here to here, generally takes how many days? Generally takes, okay, 30 to 60 days. Generally takes how many days? Generally takes 30 to 60 days. Clear? What you have to keep in mind is this entire column of air, movement towards this particular side, clear, takes how many days generally? Generally days 30 to 60 days. Okay, that is okay there. Clear? So this is okay, important thing. When we are saying this entire column of air is moving from where to where? From this position to nothing but, okay, this position. This is taking how many days? 30 to 60 days. That is okay there. Clear? Any doubt regarding this particular part? So as we discussed, this has a two, okay, what? This has a two part. One is called as a convective phase, that is low phase, and another is called as what? High pressure phase or suppressive phase. Okay, that is okay there. Which part will have a rainfall? Which part will have a rainfall? Low pressure zone. This part will have a rainfall. Rising air will create a rainfall. Falling air will not create a rainfall. Fine. Now, assume now this column of air which was over here, now is moving towards where? Now is moving over here. Okay, this column of air which was here, now moving over here. When it is now moving over here, divergence will happen like this. You see here what is happening? Subsiding is happening. Then this column of air comes over here. Then this column of air finally reached over here. Fine. So when finally it reached over here, what will happen? What will happen? End of this cell will happen. A new cell will be created. Now this new cell will again move towards where? New cell will again move towards nothing but, okay, this particular side. Clear? Any doubt regarding this one? So what we are saying is this column of air which is present over here can shift, okay, what? Can shift towards nothing but, okay, this side. This can further shift towards this side. This can further shift towards this side. Finally it will reach towards, finally it will reach to nothing but this part. When it will reach to this part, the circulation will end. Then again what will happen? A new column of air, this will start moving towards nothing but, okay, which side? Till nothing but, okay, this side. This is called as what? Madden-Julian. Okay, this is called as the Madden-Julian oscillation. How many time it is taking? How many time it is taking to move from here to here? 30 to 60 days. It may happen in 30 days also. It may happen 40 days also, 35 days also, 50 days also, 60 days also. Okay, it may happen in any of these days. That is okay there. Clear? Any doubt regarding this one? Now, assume that the Madden-Julian oscillation is taking 30 days. 30 days to complete a cycle. When it is taking 30 days to complete a cycle, and you know that monsoon in India lasts from when to when? Yeah, let's say June to September. We are taking up this one. So how many months there? 4 months. 4 months means how many days? 120 days. Let's say if it is taking 30 days to complete its cycle, how many times it will pass over India? It will it will pass for 4 times. It will pass for what? How many times? 4 times. Clear? So let's say this is okay where India is there. Let's say this Madden-Julian oscillation is created one time, second time, third time, fourth time. So it will pass for how many time? 4 times over here. And you know that when Madden-Julian oscillation will pass here, what is happening? Wind is rising, so rainfall will be more. Okay, so when Madden-Julian oscillation is passing more over India, what will happen? You'll see more rainfall. You'll see what will happen? More rainfall in India. Clear? So when Madden-Julian oscillation is passing over India, low pressure, because of low pressure wind are rising, you'll see more rainfall will happen in what? More rainfall will happen over India. Let's say the cycle is of 50 days, then what will happen? Let's say cycle is of 50 days, then what will happen? It will pass only 2 times in India. So when 2 times means what? You will see less rainfall. Okay, only because 4 times means what? More rainfall is happening. 2 times means what? Less rainfall will happen. So even formation of Madden-Julian oscillation is also impacting what? Also impacting the Indian monsoon. It is also impacting the Indian monsoon. So one of the, like we have written the factor, no, El Nino, La Nina, another thing. So even Madden-Julian oscillation formation is also impacting what? Also impacting the Indian monsoon. The more passing of Madden-Julian oscillation over India, because low pressure zone is going to be there. Low pressure means what? More rainfall is going to be there on India. Passing of Madden-Julian oscillation means what? Less rainfall will happen in case of India. Fine. Any doubt regarding this particular part? So this is all about what? This is all about your Madden-Julian oscillation. So fine. If you see the news, now you can see this. While the southwest monsoon arrived in Kerala on how many days? This year. Okay, this year you see how the Madden-Julian oscillation helps triggers the early onset of monsoon in case of India. Clear? So what you see is while the southwest monsoon in Kerala is generally arriving on which date in India this arrived? May 24. Generally you will see 8 days before. Normal time is what? Normal time is around June 1. Okay, normal time is around June 1 when monsoon comes and hit what? Monsoon comes and hit the Kerala. But this year monsoon has arrived early in what? Early in Kerala. Why monsoon do you see arrive early in Kerala? You can see several scale atmospheric ocean and local factor developed and favor the monsoon onset. The key driver was which oscillation? Madden-Julian oscillation. So what is causing this year early onset of monsoon in India is a Madden-Julian oscillation. We discussed when this vertical column of air will move over India, what will happen? More rainfall. More rainfall means what? You'll see arrival of monsoon is something that is okay happening. Clear? So even Madden-Julian oscillation also impact which monsoon in India? Also impact the southwest monsoon in case of India. This year Madden-Julian oscillation has led to what? Has led to nothing but okay, early arrival of monsoon in India. Clear? So the question might come in the mains examination, what may cause early arrival of monsoon in India? So if what may cause early arrival of monsoon, one factor we have written is what? Withdrawal of jet stream. If jet stream withdraws early, then what will happen? Monsoon can arrive in India. Madden-Julian oscillation, this can trigger what? Early arrival of monsoon in India. So those factors you have to keep in mind which can cause early arrival of monsoon in India. Fine. Any doubt regarding this one? So you can see it is what definition it is given? Moving system of wind. We discussed this vertical column of air is moving. It is a moving system of wind and pressure. It is moving. It is why it is called as a Madden-Julian, because these two person has identified. Okay, Roland Madden and Paul Julian, they have identified this phenomena. That's why it is known as what? Madden-Julian oscillation. Okay, they have identified this movement of air from one point to another point. That is why it is called as a Madden-Julian oscillation. Where it moves, in which direction it moves? Eastward direction. We have written it is moving in which direction? Eastward direction. How many time it takes to move? 30 to 60 degree 30 to 60 days. Okay, so it is moving in this direction, that is okay, eastward direction. How many time it is taking? 30 to 60 days it is taking. And as it moves, major activity often split planet into two parts. One is active phase, another is what? Another is a suppresses rainfall. So active phase is referred as convective phase and suppresses rainfall means what? Suppressive rainfall means what? We have written the air is rising and air is subsiding. So subsiding phase is called as what? Suppressive phase. Rising phase is called as what? Convective phase. Okay, that is okay there. Clear? Clear? So you can see an active phase is generally followed by what? A suppressed phase. Active phase is generally followed by the suppressed phase. And you can see multiple MGO event may occur. Clear? So if more, as we discussed, 30-day cycle means what? More Madden-Julian will occur, and 60-day cycle means what? Less Madden-Julian will occur. So you'll see 30 to 60 days, okay, phenomena, that is okay there. Clear? Any doubts? So this is all about nothing but, okay, concept of Madden-Julian oscillations. Fine. So what you are finding is, now this type of question you can get in the case of examination, discuss Madden-Julian oscillation and how it impact the Indian monsoon. Or you may get a question like, so these type of questions can come in the case of examination. One is discuss Madden-Julian oscillation, how it impact Indian monsoon. Second is, what do you understand by polar vortex? Is examine its impact, and do you think it will lead to global cooling phenomena rather than global warming? Fine. What you'll write, do you think polar vortex is leading to global cooling phenomena? Okay, more cold wave conditions are being created in USA, Canada. We discussed more cold wave conditions are created. So does it lead to global cooling? How? How do you think it will lead to global cooling? Hmm. Cooler air will become more denser. Okay, why this polar vortex is expanding? What is the reason why polar vortex is expanding? Shift in the pressure belt. Okay, shift in the pressure belt. Clear? If the pressure belt is shifting because of global warming, if the pressure belt is shifting because of the global warming, do you think global cooling can happen? If pressure belt is shifting because of global warming, do you think global cooling can happen? It depends on suns and any other thing. Anyone else?
Global warming depends on the terrestrial.
Global warming depends on terrestrial radiation. So terrestrial radiation, let's say if more heat is there, Earth is radiating more heat. So then what will happen? It will cause global warming. Clear? Because this will be absorbed by greenhouse gases. It will cause global warming. When global warming will be there, whether the air will be hot or whether the air will be cool. Air will be hot. So does this polar vortex phenomena can lead to global cooling? The polar vortex phenomena can lead to global cooling. Because one of the reasons why you see recently, if you study climate environment, in order to control global warming, what we are doing? In order to control global warming, what we are doing? All countries are coming together and taking a pledge that they'll reduce their greenhouse gas emission. Clear? Now, which country has not joined? Which countries has recently withdrawn from this agreement? US has withdrawn it. Why US is withdrawing? Why US is withdrawing from this agreement? Because all countries are coming together and taking steps that we have to minimize the climate change. Clear? We have to minimize the global warming, and that's why whatever fossils we are burning, whatever other things we are burning, we have to control down, cut down. And for this, we have to shift towards what? Renewable energy, like solar energy, wind energy. So they are doing that. But US has recently withdrawn from this agreement. Why US has withdrawn from this agreement? Because one of the reason, if you see Trump, what Trump is saying is what? You can see this. Scientists rush to bluster climate finding. Trump administration aims to undo. Whatever scientists are saying, Trump is not agreeing on that. Okay, so this is okay. What? This is nothing but okay happening. Clear? So you see, Trump war on climate science is a preposterous. Okay, the thing. Clear? Trump is not agreeing that okay, what is happening? Climate change is happening. Why? Why is not agreeing that climate change is happening? Because you are seeing more cold wave condition where? In the US, in Canada. So he's saying that if global warming is happening, what will happen? Okay, rather more heat should be there. Okay, but you are seeing more of cold wave conditions. So okay, climate change is not happening. Okay, so that's why he's not agreeing. Okay, and he's okay not following this policy led to US withdrawal from there. Clear? Now that's what the question is asking. Do you agree that okay, this can lead to global cooling, polar vortex phenomena? Now, what is this polar vortex is causing? Polar vortex is causing cold wave condition. Is it a climate event or is it a weather event? We discussed the difference between the term climate and weather. What is weather? Yeah, short period. Climate means what? Long-term period, that is okay there. Clear? This cold wave condition that is being created, is it created for long period or is it created for short period?
Long period because of Brennan's force is
Hmm.
Generally,
Generally,
it happens.
it happens due to Coriolis force. No, the spinning wind polar vortex is being created due to long. Is it causing the more ice, more other thing in US and Canada regularly or only in some part? Okay, does it causing throughout the year or is it causing only in some scenario? That does this polar vortex is causing the cold wave condition throughout the year or polar vortex is only causing this in a certain period of time? Only in certain period of time. Yes, okay, when shifting of pressure belt is happening, then you see what? Then you see expansion, nothing but okay, what? Cold wave condition. When shifting of pressure belt is not happening, then you are seeing that it is concentrated to a small region. So it is a which type of phenomena? It is a weather phenomena. Okay, when shifting of pressure belt will happen, weather will change. When weather will change, cold wave conditions are going to be there. Clear? So weather phenomena is a short term phenomena. It is not going to lead to what? Is it not going to lead to global cooling? Is it going to lead to global cooling? Because global cooling, when we are talking about entire climate changing. Climate is not changing. So be clear that the polar vortex is which type of phenomena? It is a weather phenomena. It is not a which type of phenomena? It is not a climate phenomena. Okay, it is a weather phenomena. Clear? Global, it is which type of phenomena? Weather phenomena. It is not a climate phenomena. So that's why climate is okay. What climate is not? Climate is still warming. Climate is not changing. Clear? It is only that weather is okay causing more cold wave conditions. Fine. Any doubt regarding this one? So at the last, what question is asking that, do you think it will lead to global cooling phenomena? You have to write what? You have to write, no, it will not lead to global cooling phenomena. Why? Because it is a weather related event. It is not causing the long term change in the climate. That is okay there. Clear? So those points you have to mention it. Fine. Any doubt regarding this part? So this finishes your what? This finishes your entire climatology part. That is okay there. Clear? So we started with atmosphere. We covered the atmosphere, troposphere, stratosphere, etc. Rotation we have discussed. Revolution we have discussed. Then factors affecting what? Factors affecting temperature, how temperature can be impacted, latitude, longitude, other factors we have discussed. Then we discuss what? Then we discuss the concept of evaporation, what factors, concept of pressure belt, and how these cells and etc. are formed. We have discussed that. Local wind, permanent wind, and seasonal wind we have discussed. Then we have what we have covered? We have covered the evaporation part. Then we have covered the condensation part. Then we have covered the precipitation part. That is okay there. Finally, we discussed tropical cyclone and temperate cyclone. Then we discussed the climatic region of the world. And finally, we covered what? We covered the jet stream concept. And what you have to keep in mind is what? Both this Madden-Julian oscillation and polar vortex, both are in use. These are climatic phenomena. Just remember that why these phenomena is something that is okay occurring and what impact it is having on the world or on India. So as we discussed, Madden-Julian oscillation causes more what? More nothing but okay rainfall in India, and the polar vortex is causing more cold wave conditions where in the northern part of India. Fine. So we'll start with oceanography in the next class. Okay. So we are now done with geomorphology. We are now done with now also done with the climatology part. Clear? We also discussed most of how Indian monsoon occurs. So some part of Indian geography also we have covered, like monsoonal system, what factors affecting Indian monsoon, like Indian Ocean dipole. We discussed okay the El Nino, La Nina, Madden-Julian oscillation. All these factors are affecting Indian monsoon also. So Indian monsoon also, climatic phenomena also. Now we have covered with climatology part. Fine. Any doubt? So we'll start with oceanography in the next class. Thank you. Thank you for today.